Hi guys, in this video we are going to be looking at a problem on polynomial functions. The question reads, let A, B and C be three non-zero real numbers. Given a polynomial p of degree 3 which is defined for all x in the set of real numbers by p of x equal to x minus a times x minus b times x minus c. A. Express the polynomial p in the form a0x cubed plus b0x squared plus c0x plus d0, where a0, b0, c0 and d0 are constants in function of a, b and c. Next, given that a, b and c solve the system of equation which has been given, Roman 1, find the numerical values of a, which is a squared plus b squared plus c squared, and b, which is 1 over a plus 1 over b plus 1 over c, without calculating the values of a, b and c. And Roman 2, given that p of -1 is equal to 0, find all the roots of the equation p of x is equal to 0. So for the first part of the equation, which is a, it is asking us to express the polynomial p in the form that has been given, and we have been told that the constants a0, b0, c0 and d0 are in function of the constants a, b and c. So this is the polynomial that was given to us. So to express it in the form which is required, we simply need to multiply x minus a times x minus b times x minus c, and we simplify to put it in that exact form. So we are first of all going to multiply x minus a times x minus b, then we group some like terms together, then we now multiply with x minus c to get it in this form. So multiplying x minus a times x minus b, we get x times x, which is x squared, x times negative b, which is negative bx, negative a times x, which is negative ax, negative a times negative b is positive ab, then times now my factor x minus c, which is this. Now we can group the terms here together by factoring out negative x. Doing that, we get our polynomial p of x to be x squared minus x into b plus a, or a plus b, then plus ab times my other factor x minus c. From there, we can now multiply the whole of this part with x minus c. So we begin with x squared. So x squared times x gives us x cubed. X squared times negative c gives us negative x squared times c. Now we go to the next. Negative x into a plus b times x is negative x squared into a plus b. Negative x into a plus b times negative c is positive xc into a plus b. Now we go now to ab. Ab times x is abx, and ab times negative c is negative abc. From there, we can group some like terms together. So we have x cubed, which remains. Now we have x squared here and we have x squared here. Due to the sign, we factor out negative x squared. Factoring it out, we are going to have c plus a plus b, which is this. Now these two, we have x is in common, and we can multiply this bracket by c. So we have x into ac plus bc plus ab, then minus abc. From there, we also group the like terms together here. So we have these two remain the same. Now we factor out x from here, and from here we are going to get ac plus a plus bc plus ab, then minus abc. So if we compare our polynomial which we have gotten with the standard form, we can be able to deduce the constants a0, b0, c0 and d0 in function of a, b and c. So my p of x is in this form, so I'm going to compare with this, and I'm going to get that my a0 is equal to 1 because it is the coefficient of x cubed. My b0 is a coefficient of x squared, which is negative into a plus b plus c. My c0 is the coefficient of x, which is ac plus bc plus ab, and my d0 is the constant, which is negative abc. Now the b part of the equation, we have an instruction. Given that a, b and c solve the system of equation a plus b plus c equal to 6, AB plus BC plus AC equal to 3 and ABC equal to negative 10. Now Roman 1 is asking us to find the numerical values of A, which is A squared plus B squared plus C squared, and B, which is 1 over A plus 1 over B plus 1 over C, without calculating the values of A, B and C. So we need to find this sum without getting the individual values of the constants A, B and C. So let's begin with this sum, finding A squared plus B squared plus C squared. Now we are going to use the information that has been provided. Now we know that if we square this A plus B plus C, we are going to definitely get this quantity inside here, A squared plus B squared plus C squared. So let's look for A plus B plus C all squared, what it is. Now if I let A plus B plus C all squared to be X, then it is simply equal to 6 squared, because A plus B plus C is equal to 6. So squaring it, I also square the 6. Now let's look for this quantity, which is X. So our X is simply, now what I do is that I multiply A with itself, I multiply with B, and I multiply with C. I take B, I multiply with A, I multiply with itself, and I multiply with C. I do the same thing for C. So doing that, we have A squared plus AB plus AC plus B squared plus BA or AB plus BC plus C squared plus CA or AC plus CB or BC. It all depends on you. So from there, we can group like terms together. So we have A squared plus B squared plus C squared, which is what we are interested in finding. Then plus AB plus BA, it is the same as 2AB, because BA is the same as AB. Next, AC plus CA is the same as 2AC, because CA and AC are the same. And finally, BC plus CB is the same as 2BC, because CB is equal to BC. So from there, we get A squared plus B squared plus C squared. We can factor out a 2 from here, and we get 2 into AB plus AC plus BC. Now we are looking for A squared plus B squared plus C squared, but we know the value of AB plus AC plus BC. It was given in my one of the equations in my system, and it is 3. So simplifying, we get X to be equal to A squared plus B squared plus C squared, which is my A that I am looking for, so I replace it with it, then plus 6. Now what is X? So actually this is supposed to be A and not Y. So A is equal to 6 minus X, but we know the value of X. X is equal to 6 squared, so it means our A will give us negative 30. That is 6 minus 36. So A squared plus B squared plus C squared is equal to negative 30. Alright, now the second part is asking us to find B, which is 1 over A plus 1 over B plus 1 over C. So we just look for the LCM. So the LCM is going to be the product of the terms in the denominator. So we have ABC as a product. Next, we take ABC divided by A, we get BC. Next, we take ABC divided by B, we get AC. And we take ABC divided by C, we get AB. But we know this, BC plus AC plus AB is the same as AB plus BC plus AC, which is equal to 3, and the denominator, it is equal to negative 10. It means that this is equal to negative 10. So my B is equal to negative 3, sorry, it is equal to negative 3 divided by 10. So my B is equal to negative 3 divided by 10. And that was that for Roman 1 of the equation. Now Roman 2, we have been given some information that P of negative 1 is equal to 0, and we have been asked to find the roots of the equation P of x equal to 0. So let us interpret the meaning of P of negative 1 equal to 0. P of negative 1 equal to 0 simply means that the linear factor x plus 1 is a factor. The linear function x plus 1 is a factor of my polynomial P. So with that, it means my P of x will be written as a product of its factors. So it is going to be written as x plus 1 times a certain function f of x, and f of x in this case is going to be a quadratic function. Why? Because my polynomial P is of degree 3. So multiplying x plus 1, which is the polynomial of degree 1, by a certain polynomial to have a polynomial of degree 3, then the polynomial f of x must necessarily be a quadratic, that is a polynomial of degree 2, because to get the degree of a polynomial, we to get the degree of a product of two polynomials, we simply add the degrees of the individual polynomials. So my p of x, I can get my p of x definitely, because my p of x is equal to this quantity, but I know that yes, it's equal to this quantity. Now I'm just going to replace the value of a plus b plus c, which is 6. That's to have x cubed minus 6x because of this minus. Now I'm going to replace the value of ac plus bc plus ab, which is 3, that is it, positive 3, then minus my abc is negative 10, that is why I have minus negative 10. So simplifying, I get my polynomial p of x to be x cubed minus 6x squared plus 3x plus 10. Now we need to find all the roots of the equation p of x equal to 0. It simply means that we need to find f of x, because we already have one of the roots, which is x equal to negative 1. So we need to look for f of x, and we also equate it to negative 1 to find the remainder of the roots. So let's look for f of x. Now I'm going to show you guys two different ways to look for f of x. First, we are going to use Euclidean division to look for f of x, because in this case, if I take p of x, if I divide both sides of this equation by x plus 1, I definitely get f of x. So I'm simply going to do the long division of p of x by x plus 1 so that I get the quotient, which is f of x. Now the long division, follow up keenly. So that is my p of x divided by x plus 1. Now we begin. X cubed divided by x is going to give us x squared. X squared times x gives us x cubed. X squared times positive 1 gives us positive x squared. Now we subtract. X cubed minus x cubed is 0. Negative 6x squared minus x squared is negative 7x squared. 3x minus nothing is 3x, and 10 minus nothing is 10. Now we need to divide this quantity now by this quantity. Yes, we can take this divided by this, but this is factorizable into what? Into this, negative into x plus 1 times 7x minus 10, meaning that we can just take this whole quantity divided by x plus 1, and doing that we are just going to be left with negative into 7x minus 10, which is the same as negative 7x plus 10. So taking this divided by this, you get negative 7x plus 10. Multiplying this and this is the same as multiplying this and this. Considering the negative sign, we still get back this same expression, which is the same as this expression. Now we subtract and we get this quantity minus this quantity. This minus this is 0, this minus this is 0, and 10 minus 10 is 0. It means that my p of x is equal to x plus 1. Now this is my f of x, because it is the quotient when p of x is divided by x plus 1, since the remainder is 0. So I'm going to multiply it with this. Now let's try to factor out x squared minus 7x plus 10. Factoring it out, it is clear it is x minus 2 times x minus 5. So my p of x becomes this times this times this. Now I am solving the equation p of x equal to 0. It simply means that I equate each factor to 0. So x plus 1 equal to 0, x will be negative 1. X minus 2 equal to 0, x will be 2. And x minus 5 equal to 0, x is going to be 5. Now the second method, I'm going to use the information concerning a, b, and c. Now we have been given that p of negative 1 is equal to 0. Originally, these are the roots. The roots of this polynomial is a, b, and c, because the factors are x minus a, x minus b, and x minus c. So if p of negative 1 is equal to 0, it simply means that either p of a is, because from here we see that p of a is 0, p of b is 0, and p of c is 0. So we can fix maybe a to be negative 1, or b to be negative 1, or c to be negative 1. So if we fix a to be negative 1, we can rewrite this system as follows. We fit a to be negative 1, we have negative 1 plus b plus c equal to 6. A, negative 1 times b is negative b plus bc. Now negative 1 times c is negative c, then equal to 3. and ABC, we have negative 1 times BC, which is negative BC equal to negative 10. Alright, so from here we can add 1 on both sides to get B plus C to be 7. Here we have negative into B plus C. If we take the negative out of B and C, which is you get negative into B plus C, then plus BC to be equal to 3. But negative into B plus C is the same as negative 7. Sending it this way, we have 3 plus 7, which is 10. And here we can divide both sides by the negative sign, and we get BC to be equal to 10. So you see these two equations are the same. Now we can clearly see that if I have a certain quadratic equation whose roots are B and C, the sum of roots is 7 and the product of roots is 10. It simply means that this quadratic equation, which is x squared minus 7x plus 10, is going to have probably, if the roots of this quadratic equation, of a certain quadratic equation, is B and C, then this is the quadratic equation in question, because the general equation is going to be x squared minus x times the sum of roots. The sum of roots is 7 times x plus the product of roots, which is 10. So we see that we can rewrite this maybe in function of b. We can write it as b squared minus 7b plus 10 equal to 0, or in function of c is going to be c squared minus 7c plus 10 equal to 0. We can see it clearly. If from this equation we look for b, or we look for c, c is going to be 7 minus b, and we replace here, we are going to get this, and this is equivalent to this, but now in this case we are in the x whole, but we consider b now as a variable because we are looking for it. So from there we see that b will be equal to 2 or b will be equal to 5. If b is 2, then c is going to be 7 minus 2, or 10 divided by 2, and if b is 5, c will be equal to 10 divided by 5. So we see c and b are either 2 or 3. So either it is 2 or it is 3. So definitely anyone you use, you're still going to get finally x plus 1 times x minus 2 times x minus 5, and you still get maybe your a to be negative 1, your b to be 5, your c to be 2, or your a to be negative 1, your b to be 2, and your c to be 5. It all depends on you. So that's it for the video.